Hello, everybody. In this video, I would like to show you the SD Access Fabric border design considerations. This is important if you are planning to deploy SDA Fabric. So I'm using Cat9kv for this lab, and also I'm using the Cat9k, the virtual ones, for this simulation. In this case, I'm using some kind of holocade deployment, which basically means that I have my border node and control plane node running on the same virtual switch. When you have this type of deployment, where it's not a full mesh topology, if the border node 1 loses the uplink to the fusion, right? This might lead to a potential black holing of the packets, right? So let's understand why. So as we use ISIS, that's the IGP protocol that we use to build the underlay. And then you have your overlay that is using LIS, VXLAN, and everything about Cisco Trust. Please use RLOC to identify the next hop. In this lab, the RLOC is equal to the loopback. I'm using loopback 0. You need to consider how the virtual switch communicate with the border node. In this case, the Fabric Edge 1 is able to reach the border node 1 because that loopback is reachable. When you check the Fabric Edge, it has two sessions, one to the border node 1 and one to the border node 2. These sessions will remain up. Okay, so the problem will be when you try to exit the fabric, right? Because in this case, the RLOC from border node 1 is still reachable. You just lost the iBGP that this border node has with the fusion device, but the ISIS remain up. So basically that specific RLOC, which is that specific loopback, is still reachable. That's when you might see the problem with the packets loss. So it's something that you need to consider during your deployment. So what is the recommendation from Cisco is you can form iBGP between the border nodes, right? And that BGP or iBGP, it's for every configured network, which means for every VRF that you have, you need to configure iBGP. Now, in this case, I have only one VRF with a corporate VRF and my global routing table. Let's check what we have in this lab, and let me show you some commands that you can use to double check these. Okay. So we're going to use for this lab the PC that is connected in port 10. So let's see if this PC is fully authenticated. Show authentication session interface. Okay, details. Okay, so the PC got an IP. Let's double check. Okay, what is this PC? 24100. Company. Okay, so this is the PC, right? 66.10, and I'm gonna ping this .100. This IP is outside my fabric, which is this management PC. Let's see if I can ping that specific 255.100. Okay, so I have network connectivity. Let's check the session. It's something that you can see here. The sessions that this fabric edge has with both border nodes, right? So Lisp session, and you will see that I have that 250 and that 251, and the state is up, right? For now, forget about this one. This is for my guest, for my Encore guest. So I'm not using this at this time of with this lab. But as you can see here, we have two peers, which is the border node 1, border node 2, and let's confirm that. That's related to the loopback 0. Interface loopback 0, right? That's 250. And this is 251. If you check the Lisp database, you will see that I have the endpoint ID, and this is the RLOC, which is the loopback of Fabric H1. Let's confirm that. We have network connectivity. Let's test this if we suspend this link. So as you can see here, I lost connectivity to the PC, the management PC. So let's check what we have here. Here, basically the same thing. The sessions are still up because the Fabric Edge is still able to communicate with that specific loopback. So the RLOC is still up and the session will remain up. As I mentioned before, we need to configure iBGP between these two border nodes, right? So let's configure that. Just let me check. I think I have a template here. So let me show you. This is border 1. So what I'm gonna paste here is a new VLAN that's only for iBGP between the border. This is the IP. For corporate, I have my BGP and neighbors, right? This neighbor is the border node 2. So let's paste this. Right. And let's do the same on border node 2. So let me paste this. Okay, so 800. Okay, this looks good. Let me paste this. In this case, I'm configuring SVI, right? And this is a trunk port. If you have multiple VRFS, you can put different SVIs per RF, right? And this is a trunk, so you just need to allow the specific VLAN. Let's see what we have here. Trying to BVP summary. This is still down. Section BGP. OIP interface rate. I'll assign it. My billions are up. Let me see if I have the actual interface. Protocol 1. I think it's 1. Okay, I need 106. That's the configuration that is missing. 106. So I mentioned this should be the a trunk port between these two, or you might create sub interfaces if you want, like layer 3 and create different sub interfaces. That's also possible. Well, trunk. I need to do the same here. Okay, let's see. Now, as you can see here, my iBGP session is up. Show BGP, VPN4, unicast, VRF, and remember that I have just one VRF, which is the corporate one. My iBGP is up. So let's see what happened here. Okay, we have now again network connectivity. Now, something that I would like to mention to you, hopefully you can see what might be your problem here. Because yeah, the corporate seems to be working, right? This is part of my, if we check the interface where this virtual PC is connected, let's put it, no, show authentication, what is this here? This specific PC is part of the VRF core, right? But something that I would like to mention here is it depends how you deploy this, because sometimes at the beginning, because you don't have BGP or your eBGP is still down, right? Because you haven't really pushed the layer 3 handoff, you might see that you still have this specific static route that is still here. But that specific next hop is not reachable from this border. So 10.196.94.246, right? So in this case, this specific device is still thinking that this next hop is reachable, right? This is because it's something that I needed when I started the discovery of this device, right? Because you don't have any, you have ISIS, but you might not have IS neighborship with the Fusion device. So you can use a default route pointing to the Fusion device, so DNA will be able to reach that specific border. So let's do something. Let's change this. Show running. I don't need that. So let's go here and let me change the administrative distance to 254. Right? So let's see what happened here. Okay. Let me check. Okay. So now, as you can see here, now you have this default route through IS. So this should work because you are using VLAN 100, which is the next hop, which is a border node 2. But as you can see here, you are now using the iBGP sessions like that you have between the border. Anyway, you still have network connectivity, but you might need to double check if this is what you really want, right? Or you really want to learn this specific default route using iBGP. Hopefully this can help you at least to have a high level overview about something to consider when you are deploying your SDA fabric. Thanks for watching.